Perfect. All right. Welcome, everyone. Good morning. We are up in a bit with our second talk from Martin Beránek from ShipMonk, and he will speak about how you can reset databases at scale with Argo. Hundreds of environments, imaginary downtime, and a rational bill. So without further ado, please welcome Martin Beránek with big applause.
Thank you very much for coming. I was kind of trying to compete for the longest title of the presentation, but then there is the other one which is longer, so it is what it is. So every great story starts with a problem, obviously. We have a lot of problems. We are problem solvers, that's why we're here. Like when you have a thing and you just don't have it anymore, the typical complex problem which we have to solve every day. I still can't find my crimple pliers. I just put them somewhere. They were there at the moment, but they are not anymore. Laundry is a problem. All of that stuff. But for us, the problem shouldn't be copying the databases, right? This is the example from Postgres. That's so sweet, right? You have like a source template, database, you are using some production or something, and you would like to create a new database with entirely the same content, all the data, all the schemas, all the stuff, and you just write this little command and you are done. It's just amazing. And I would really like to appreciate these 2 lines, because the rest of the presentation, the rest of 30 minutes you are going to spend here with me is going to be about how it's not done in some different databases. So I just hope that you are in the right room, you can still leave, I don't blame you. This is how it's done for MySQL. It's just, and I'm not even like trying to hype up some kind of story, this is from the official documentation, it's kind of small, but it's kind of, claiming the same. If you want to copy the database, you just have to dump it and import it again. In a way, it just doesn't really seem to be any problem for like a small databases, something reasonable. And we kind of all know that it's not going to be what I'm going to talk about, It sucks. And it takes hours, it takes additional resources, you just have to get the data from somewhere, put it on something else, and just, putting them back in. That's the problem. Who am I? I kind of skipped that part. So I'm basically middle manager. I just lead an SRE team. It's an SRE because SRE is kind of trendy these days, but I hope I'm going to change the name pretty soon, since we were before that like DevOps engineers, infrastructure engineers, and still kind of doing the same thing. So that's what we are doing now. We maintain and focus on automation for the ShipMonk infrastructure, which, even though ShipMonk celebrated like 10 years 2 years ago, it is kind of obsolete in plenty of things. So that's why this talk, and that's why also MySQL, ArgoCD, and all of that things around it. So why dumping and importing? Why are we actually like talking about this issue in the first place? So there is this thing called environments. They are specifically, explicitly mentioned in GitLab CI. That's a thing. You can deploy them. If you have the infrastructure around it, you can provide it to your developers. And we did, and it turned out to be like a great thing in 2019, where everybody can just click on a button and have their environment ready. It turned out that everybody can be, testing on almost a full production setup, having all those backends, all the services, even like third-party integrations. And it actually means that data have to be up to date, obviously, So in the end, if they actually click on the button, they have the environment looking exactly as the application running in production. This is like a dev staging, but the same thing could be deployed for any merge request they have. This is the workflow doing the thing. I was kind of hoping that you can actually see it all, and I tried my best to fit it onto the slide. But as usual, it's not that simple. I got a feeling that everyone who's ever working on any workflow has a similar issue with that. So original workflow, only 55 jobs, 200 megabytes of a snapshot. So it's obvious that you are not really getting full production, but at least you are getting something you can work with. It took like 5 minutes to run it all, so it's kind of reasonable, you know. It's like a coffee break or something. If nothing is going to fail, you'll get your environment in like reasonable time. So people are just clicking the button, and behind the scene, the snapshot is downloaded. There is this set command adjusting the timestamps, so the snapshot is pushed into the current, day or something workable with, and that's done. Again, 200 megabytes. Even that took like 5 minutes. Each of that environment is then represented as in Kubernetes namespace and so on. Other stuff, happy stuff related to it. And I have to say, at the beginning, seems like a good idea. Nowadays, 10 years later, like 10 to 20% of capacity of my team is purely dedicated to keep this alive. So, just saying. And then we have demo environments, and everything changes from like one perspective to the other. Previously, you had developers, running the environment, being happy about it, developing on it, and if they have any issues, they generally can read log messages, and with introduction of Claude, they can like help you out debug the issue. They are just not asking about the stuff which is obvious to you. But then you have salespeople, happiness engineers, all of that guys who actually want to show something to the possible, customers, for us merchants. And they also would like to have something else in production because they do not want to introduce customers right in the production before they know that they are actually committed to be with us. So that's why we have demo environments, which in a way sounds like something which is not really production related. So it was my first on-call in ShipMonk where I totally ignored demo issues because for me it was just yet another environment. And I was like reminded that it's not really true. So it's actually very production-like, and the input from user is hard to work with, let's put it this way. And what are you actually dealing with? Like, what is the database behind all of this stuff, behind the application? And we all actually understand in a second that it's just old, it's like a huge monolith. There are tables like orders with S in the end, all of them, all of the orders coming through ShipMonk, they are still there, log. And that's not like a log of application, which is nice. It's just the audit log of the actions of the developers, which makes sense. Fulfillment, there's like a whole process of logistics. If you are not familiar with the logistics domain, that's like everything happening from accepting the package, putting it into the warehouse, and pushing it somewhere else, and so on. We have actually like a table called event because somebody read something about event streams. So we have like one functionality dedicated just for that. The guy who actually read the article already left, so it's not actually developed anymore. But it's still there. Yeah, and so on. So in practice, it's just big. And it's like gigabytes of data just for the demo. So instead of like 200 megabytes being pushed here and there, you are getting at least 20 being downloaded, adjusted by set, and pushed back into the database. And also, you still have to do some kind of operation with the timestamps, right? You just can't push the snapshot back into the database and just pretend that it's in the past and it's all right. Especially for the demo environments, because you would like to show the customers that their packages are being delivered on time. So we also have to fake the dates. So every problem gets a reasonable number of infeasible solutions. None of them is optimal, that's what we know. And one is feasible, like doable and stuff. And of course, you can always buy the power, like buy it from AWS, load the data from S3, use point-in-time recovery, which kind of makes sense if you want to roll back to some specific time and just use it again and again, or just clone the whole cluster. And we explored those solutions. For S3, it's pretty easy. AWS actually advertised this functionality as this. You can use the data being directly loaded to RDS. It's pretty fast, but it really wasn't for our use case anyway. So that was like thing we haven't really did. There's point-in-time recovery, which makes sense. Every morning the demo is being refreshed to the previous state. So just click on, please restore it to the way it was. We found out that it's kind of expensive for us because we are keeping really long bin lock just to enable this functionality. So we kind of compromise, and instead of just relying on the bin lock, we are copying the whole Aurora every morning, which is in the end a tiny bit faster. So that's the winner, and we'll still have to deal with the timestamps because since we are making a new copy of the database every morning, we have to adjust the timestamps afterwards. Increase of the cost by 100% because you just have to deploy a new database for the demo, which then had to be explained to the procurement and people making budget. So that wasn't really like that easy. But still, it's kind of easier to explain the additional cost to the people who are selling something to merchants rather than, saying that you'll have to get some additional expense of the platform about the stuff people do not really understand in the first place. So that's why we are actually reaching to Argo and the Argo ecosystem altogether with all the stuff related to it. We started using it pretty soon from the introduction. So that's why we kind of have it, and I kind of wanted to put into the context, like how old is the stuff we are talking about. So Kubernetes 2014, right? It's not new, right? Like even Argo 2017 and all that stuff around it, it's crazy. For me, something which kind of nice was that GitLab CI is 2012, well before, well, not well, but 2 years before Kubernetes. So we are still using it. We did try some alternative, but in the end, we still stick with YAMLs and all that stuff, which was really familiar to the team and could be worked on. So a few words about the ecosystem altogether. It's kind of small again. I'm sorry about it. But you have this ArgoCD, which is continuous delivery part. And from the perspective of my team, delivering something as a platform to the developers, the biggest value in this that we can actually show everything to the developers and they actually know what's happening. Instead of like listing lines, going through a control plane, checking the stuff in the console, they can see everything. There are no questions. It's just bubbles going here and there. The same actually is could be said about Argo Workflows, which by the name suggesting is just workflows done in Argo, which are nice, fairly observable. Could be sometimes hard to manage, but it is what it is. What we are actually struggling with is Argo Events, which is nice. It's like an interface for you to the whole Argo ecosystem. It has all these sensors which could be used for webhooks, pops up, and all of that stuff. But in the end, we just use calendar event, crons, and that's it. But even such a small set of services actually requires another Argo platform thingy. So that's the way it is. So what was the solution in the end? Sorry. So instead of using one command from PostgreSQL, we just had to create a workflow which does the discovery of the cluster we would like to clone for the demo. We would need to wake up the demo base instance, and that's just because we would not like to have running RDS and just costing us additional money. We need to shift the timestamps, which in the end proved to be the hardest problem out of them all. We then need to cut over from the old demo to the new demo, wipe the ephemerals, those are like Redis, Rabbits, all of the related services, and then just some redeploys and exit handler with emitting some traces. And again, I try to kind of show you, I would like to show you the whole workflow, you know the drill from previous. I wanted to do something better this time. So it's not like, at 45 degrees angle. So we'll have the chance to see it all. Instead of having 50 jobs, now it's 538 jobs, 14 steps, but 20 gigabytes of data being pushed from the previous database to the new database every morning. 1 hour and 10 minutes of runtime. Amazing. Here is the workflow. This is the part which is cut. I kind of wanted to, fit it all. So it's here. And this is actually the most important part. This is the adjustments of timestamps. Each table has to be adjusted. It had to be done in some way that the database wouldn't break under the load and so on. So this is the representation in Argo. One tiny job at the end. That's just putting the traces into the data doc, for us for future reference to have some kind of monitoring. How to write it? I think this is like the most reasonable part. You can learn something or I don't know. Depends on your know-how. So we mainly rely on JSONet. For some reason, it was close enough for us to understand as in JSON and also as in YAML. We didn't have to study a whole new language, which tends to take a few days, even though you can wipe code it these days, except you wouldn't understand because it's wipe code. No, never mind. So everything is just written in JSONet. We rely on the libraries. There's this Kubernetes libsonet library, which you can just import into the files. And if you introduce this JB as an JSONet bundler, your code could be just looking like this. Just import the library, and the whole deployment could be just 3 lines. Fairly, understandable code. I don't know, depends on your liking. Thing is that you just don't have to write deployments, all of that stuff again and again and again. And the only thing you have to do with regards to ArgoCD to deploy that stuff is to implement or just deploy it config management plugin, which actually says to ArgoCD hey, in case there's this JSON file JSON, it might be a good idea to initiate with JSONet bundler, install all the libraries first, and then you'll be able to render all the YAMLs, all the manifest, which could be used in your Kubernetes cluster. So that's kind of nice. It's probably usable. It helps us to keep the code clear. So that's one of the suggestions. And this is the slide, addressing that huge slide of the jobs, I showed previously. This is how we are actually adjusting the timestamps. So basically, it's just a normal shell script. It could be something else, of course, but it turns out that people actually are able to read really small shell scripts. So these are really small, and the only thing they do is just, just read the database, get the columns which have timestamps, check the timestamps, and push them into the different date. And they do it in a batch of 16, because it turned out that if you are trying to adjust that more than 500 tables at the same time, database tend to crash. So 16 was a number which was doable for our setup. So that's that parallelism part at the step block of that YAML above that. The thing is that once the workflow is rendered, just because of these 500 tables we need to adjust, it actually generates 42,000 lines of YAML, which could be also read from Argo Workflows itself. But if you are not AI, you just avoid doing that altogether. This is one hint how you can actually write it. Promote clone libsonet is actually the workflow itself. It's just again libsonet with some steps which are taking the time in parallel and sequence and so on, and then a lot of small scripts which are really easy to use and kind of debug separately. Yeah, discovery is the largest one, And everything else is up to like, what, 50 lines of code, which is still something you can test. You don't need to really worry about it. And you can like test it separately from everything else altogether. So what is the base? This is like the explanation of the previous. I said that discovery is actually the longest shell script there it is. 184 lines, and what it actually does, you just have to know what's the base database in the first place. So it turned out that people know how to label, and in AWS you can use tags. So if you tag something correctly, it's kind of easy to find it, even like for the script. So the base database here is mentioned in the usage. So if the usage for the database is base DB template, it's going to be used as a template for the other clones for the demo environments and so on. There are some other tags which are marked up there. One of them is actually showing the create timestamp. So at what date the demo base is actually currently at. So you can like move the timestamps into the future based on that tag in the specification of the database. One other kind of funny one, the clone place into the target group one. It's just a small lambda which checks the RDS endpoint and puts it to the correct load balancer or behind the correct load balancer. I have a few words about it afterwards. So basically, you can just switch the demo database based on the tag, and once the workflow is done, it's going to be considered as a new clone. And again, as I was saying about those tags, like if you miss something in the cloud, you can always write some Lambda or cloud function about it. And I showed the one about putting something behind a load balancer, and there has to be another one. And this is kind of a funny problem. You can turn off database in AWS. That's doable. You can do it. But AWS is going to miss a lot of money because of your decision. They are going to charge you for the storage, of course. But in 7 days, they will turn the database on again. Don't know why 7 days. Maybe some American inspiration in some Catholic literature. But it is what it is. So there has to be something stopping proactively the database every time it's going to be turned on. So again, if you don't have some functionality in the cloud, just write a Lambda about it. And this Lambda just goes around and just stops the database if it's supposed to be stopped. Which is kind of crazy if you do not know the setup and just go start the database, and after a minute or two, it's going to be stopped again, and so on, because there's this tag and magic regarding that. This is the explanation about the load balancing and so on, which is kind of nice, but I would still like to have the native functionality provided by AWS itself, but it is what it is. What it actually does is just checking the tag, and if there is going to be a new instance saying hey, put this instance behind a load balancer, it will do it for you. And it actually enables us to do some sweet stuff regarding a cutover. We can be deploying new demo database. It could take hours. Nobody would notice because the cutover to the new database will take place once everything is done. So, summary. I think still on time. It turned out that developers are able to use workflows. They call it DAGs, and okay. So they were able to debug it with us, which is great because then we have their involvement, they buy in and so on. Everyone can read shell scripts which are reasonably sized, even AI. So that was really helpful. The time machine actually turned out to be miserable in sense of taking the lot of workload, a lot of time. But it has to happen because other than that, you just don't have really any reasonable solution. We were looking into some, procedures which could be run in MySQL. Those are really hard to debug. The support regarding that is just something really old, And after like doing some benchmarks, it turned out it's still easier to run the jobs aside, 500 of them, and adjust the timestamps separately from the database. It's fairly observable. If you are familiar with these three tags, you can like create your demos, run the workflows. It's nice. And the previous statement, which I think forgot to mention in the first place, like, can we do it under an hour? Well, no, but since the cutover to the new database is done separately on the demo environment itself, nobody actually notices that something is happening. So it's like new demo database is created, everything is done, and then it switch over, and it can take an hour, 8 hours. It's still all right. So all in all, fun project. Enjoyed it all. AI had fun. It haven't really cost that much tokens. I'm not even paying for them, so that's all right. What was really nice, the developers actually understood it as well as we did, which is great, especially like, if somebody from, managers tends to do this, like, hey, you have to cooperate with developers. You are just not the platform. You have to deliver some value and so on. So this project actually fulfilled it as well, because even salespeople can use it afterwards. So that was nice. No MySQL dump. So that was actually pretty nice. I know that there are some alternatives like MySQL, SH, and so on, but they tend to be also really unstable with large set of data and so on. Yeah, so that's it. Cool, I'm on time. Just like fun little project I was really happy to share with you guys. Not that many people actually are asleep at the moment. I take it as a compliment. And enjoy your day if you have any questions, right?
Yeah, thank you. Thank you so much, Martina. Yeah, I think the Slido is live, and it's also live on my machine. So with that, I will be very happy to review the questions. Any questions from the audience for the start? All right. Check it out. Slido is open up right there. Yes, sure. Yeah, I will bring you the mic.
Thank you. Can you hear me? Yeah. I wanted to double check or clarify the demo environment was single one, or do you had more of them? Because that was kind of the point you mentioned, that you don't want to run infinite number of demos for each customer maybe. So I want to double check that.
Yeah, that's a great question. The thing is that sales would like to have new demo for each of the merchants, just to see, just to have something separate for them. And we manage that argument in a way that it's going to be really expensive. But in the end, we still end up with like having 4 demo environments for different purposes. So again, since dev environments tend to be really small and developers are pretty okay with running stuff on spot instances and so on, that's all right. But for like demos, it tends to be expensive just because everything has to be like almost production-like, very stable and so on. So it's still around that number of 4. But hopefully it's going to be much less in the future, just because that's where I kind of tried to mention at the beginning. The expectations of developers from anything is that, hey, it can fail. But sales and people interacting with the application, they do expect really high availability. And, at the end, it just shows up to be really expensive. So it's like 4 of them at the moment, and hopefully the number is not going to be bigger. Yeah, thanks.
Okay, thank you. Thank you.
Thank you so much. There's one question from the Slido, so let me read it out loud. When you showed the 500 job pipeline, how often is the pipeline actually successful?
Oh, that's every morning. It's still the thing is that we struggled a lot. That was our limit. I was kind of like pushed into it. In the end, everything you run depends, but for us, everything you run in the workflow materialize as one job, one pod running in Kubernetes. So longer you run your pod, higher the chance is that it's going to be evicted, something wrong is going to happen to it. So if you give yourself like a hard limit of 10 minutes, put there some pod disruption, configuration, set up the annotation correctly, for toleration and stuff, like 10 minutes of the runtime is still kind of reasonable. So it does finish correctly every morning for, I don't know how long, like quarter of the year already. And of course, there are some things which fell from time to time. The thing is that if adjustment of the timestamp fail, you can just retry it. It's still one table, and it's not going to go anywhere if you have your transaction set correctly and so on. So it's fairly reliable.
Fair enough. Thanks. Yeah, let's take this question.
My question is regarding Postgres. On the first slide, you said that Postgres can clone a database in one line, in two lines in a few seconds. But I doubt that it is possible for your use case because, as I understood, this is possible only if in a single server, Postgres server, and if you usually have production environment, you have demo environment, you have sales environment, and they have distinct databases, MySQL in your cases. And in Postgres, this means that this command for the first slide will not work, actually, because it needs to make a copy of database between different servers, not in a single server.
I got it. And that's a correct way how to think about it. But for maybe I didn't understand correctly. For us, we try to keep everything in like single instance for a really long time, especially for the MySQL, because it's still MySQL. Once you actually put it somewhere else, you just have to pay the tax of putting the data out and in and so on. So like for most of the apps running on that huge monolithic backend I was explaining at the beginning, the database or the instance is just one. So that's the thing. And the point is that the PostgreSQL command wouldn't work in the first place anyway because it's still the same instance. The multiple instance setup is just a result of the issue we had, because like cloning the whole SSD drive tend to be much faster than just doing MySQL dump and then importing it. So that was kind of the point. But yeah, good note. Thanks.
Okay, thank you. I know there's one kind of related question in the Slido. Do you plan to migrate to Postgres?
Yeah, I would love that. The thing is that for some reason, I'm not the only one who's making the decision. And again, the problem is that huge monolith. Like every time somebody tries to cut some functionalities out and creating new service out of it, it's just taken, incredible large time. And that's the point where you actually need some manager who will just go to the people and explain to them, hey, this is needed. We have to do it in a different way. And I guess like every last one of us have the experience like this. Explaining somebody from sales, for example, that they need to wait for like a half a year because we need to do some rework and restructuring something, that just sucks.
Got it. Thank you. Is the question still valid? Sure. So go ahead.
Thank you for sharing information. It's from inside. So the question is, what do you using for the managed cloud resources for all of this running of the workflows? I mean, engines like possible crossplane or whatever else. Terraform, what are you using?
Oh, yeah.
I mean, anyway, you have to adjust the resources dynamically, not just keeping off all of this always running.
Yeah, the basic setup was in Terraform, but since you are like copy pasting the database every morning, we solely rely on that workflow to not get crazy. Because you would then have to still go back and adjust the Terraform state, but it turned out that it's not really like needed in that sense. You know, like everything you change in Terraform tend to get changed back by those Lambda functions. And that's something which is fairly misleading, you know, like those labels and tags, we tend to think about it as an annotation in Kubernetes. You know, you annotate something and it's going to somehow get some different behavior fulfilling your desired wish based on that annotation. You know, like, I don't know, like some setting in ingress and so on. The same behavior could be done in resources in AWS, even though it's not like visible on the first look. You just have to go into the tags. So managing that is not easy. That was my biggest worry. If I'm going to fail something, just forget about it. For like 10 days, I'll have 10 same demo databases costing us fortune. So it turned out that after some like rigorous testing, this could be avoided. But yeah, I kind of got the picture. Like having the state at the moment is not really that easy, since you always have to check what happened.